Good morning, guys. So today we're going to be talking about oil grooves, or you can call them spirals and whatnot. So this can be done on ID and OD. And today, what are we going to be talking about is oil groove like this. How to do it. So as you see, the oil groove on here, it starts right off the line, and then it blends into that undercut that we have in the middle. The way that the oil groove is, or we can call it spiral, is described is 120,000 plus 10,000 wide, 30,000 deep, and it's the internal spiral oil groove, and run out to the undercut, 3 inches groove pitch. So the way we do that, when we put this part back, is we do program it as a thread, and I'll show you a program, and I'll show you also how it runs. Okay, so let's just say that to do that part, I'm using a grooving insert that's 125,000 wide. I did set it as a threading tool. So 0.62 feet to library. As a thread in, and it's called 0.62 because it's a 5/8 bar. Okay, so let's get back to the floor. So this is a thread in. As you see, there's a little cross. That means there's a TPC set up to it. So we have a chamfer 0. Lead is 3 inches. It's gonna be, shut off the light. It's gonna be that 3 inches. So I've done a previously video on threads. So for example, like if you have thread number 8, the way you come out with the lead, so that's going to be 8 threads per square inch. So you take 1 divided by 8, and that's going to give you 0.125. That will be your lead. So we're telling the machine that there's going to be, the lead is 3 inches. So it's going to be 3 inches. So automatically, this is pretty much the whole turn will be per 3 inches, and since we let's say going 1.5 inches, you're only gonna see about a half of it. You're gonna see like 180 degrees, let's call it angle 0, because we are using grooving insert, 1 entry, and the height is 40,000. So normally when it says that the height is gonna be 30,000 deep, I put it 40,000 just for the fact that I started 10,000 lower. Okay, and then you have your tool. The depth is going to be 2,000. Surface speed is going to be 20. This is the manual code for barrier cancel, and then these are your dimensions. So the dimensions you put in are the final dimensions. So the final depth is going to be 1.75, starting at 0, and then go to 1.75, and we're going 1.80. Let's see what we can find out in a TPC here. Now we have to go. Right here. So pretty much over here is just safety clearance in, point 2. Now remember that if you're going to write a program on the thread, and let's say you're gonna set your speeds and your feeds on auto, the depth, and not the cutting depth, but the height of the thread, it's gonna be super high. So anytime you're doing a spiral, and let's say if it's gonna be like a huge lead, like let's say one revolution, 1 inch per, one revolution per inch, not square inch, but just per inch, it's gonna have a really huge height. So height has to be adjusted, and then whatever speed you're comfortable with.
Let me see if that came off.
So this is the tool that I'm using. It's a top notch insert. But when you look at the top, it's actually kind of grinded to the point. Let me see if I can focus on it. So it's kind of grinded. So you get a better relief. It actually runs pretty good. So what I'm gonna do is I'm gonna pause this video. I'm gonna run another piece, and before it's gonna thread, I'm gonna show you how it looks. It looks pretty scary the first time you do it, but it's same thing. Before you run it, make sure you don't actually have any part close to it. Do like an air run, see how it runs before you actually start cutting the piece. So quickly, so the way I run this part is because the part sticks out very far, and I was getting a chatter, so I actually take her to clean up the face. It's like pretty much all over the place, maybe it'll be easier to do this way layout. So general out, so I do clean up the face, then I make a center for the drill, I drill, then I do ID turning, then I do ID finishing, but I do leave 2000 stock. I'll explain later. Then I do use a 0.62 G, which is a 35-degree bar, the way I set it up, because actually it makes that undercut. It was just using a grooving bar, I was getting too much chatter. So this is raw finish, this is that thread in. Then I come back with the same bar, and I do one pass in the air to get rid of the burrs from the threading or from the grooving, the spiral, and then I do another pass which removes about 1000, giving me a nicer finish. Then I rough the OD, okay, and then I face the OD for finish. Then the tailstock comes in automatically, and this is where I start finishing the OD. Then it's all the grooving, milling, and that's all being supported. Then the tailstock pretty much, leaves, it goes back home, and then that's where I cut off the part. And I cut off the part, leaving almost no stock, or I'll just kind of gently hit it with like a rubber mallet, and the part falls off. So we're gonna be almost ready. This is gonna be that 5/8 bar that's called 6.2G. make an undercut. The good thing about this job is this is bronze, so it's pretty soft. You can do that in the metal too, but the same thing is you have to, carefully adjust your cuts and everything, because once you get to these spirals that are, like I said, 3-4 inches, it's gonna go pretty fucking quick. So you don't want to crack your inches. Okay, it's gonna finish. Let me just wash off the spray some coolant. Okay. So this is how it cuts that spiral. So as you see, it takes about 1.5 inches acceleration before it hits the part. These things can also be adjusted in TPC if you don't have that much space. But for example, if you do this on a longer shaft, and it would start somewhere in the middle of the part, then you would have to compensate for that. Let's say if you start from, you would have to start from 3 inches. If it accelerates 1.5 inches, then you would actually have to program it to start from 1.5 inches. That way, the machine thinks it's cutting in 3 inches, but it literally cuts from 1.5 inches. So yeah, this is how you do these oil grooves or spirals, and the same thing. You just program it, like I said, you just program it as a thread, just like a thread. Just make the cuts a little bit smaller. It depends on the size, and slow down the RPMs. And usually these things work out pretty good. And like I said, figure out your starting spot. So pick up your offsets a little bit. Look at the position where the Z, let's say, starts. So if according to the blueprint, if you have to start, the spiral starts at 1 inch, and this thing starts at 1/2 inch, then just back it up a 1/2 inch to make sure it's gonna start like where you want it to go in, and that's how you kind of learn, and that's how you start these things. It's like I said, in TPC you can change acceleration, distance, but I usually don't. I just kind of change it in the program, and once you do it, if you're gonna get that similar job and you save the program, you should be up there. Thanks for watching, and see you soon.